Welcome to StarTalk Radio. I'm your host, Neil deGrasse Tyson. I'm an astrophysicist with the American Museum of Natural History, right here in New York City, where I also serve as director of the Hayden Planetarium. Come by and check us out sometime. I've got with me Leighann Lord, comedian extraordinaire. Leighann, welcome back to StarTalk.
Thank you, Neil. Good to be back.
I got you for this special needs of this hour. Not special needs. That didn't come out right. Special needs. Are you a special needs?
Well, you know what? Actually, I think it did come out right because these questions make me feel very special.
Oh, because this is the Cosmic Queries part of StarTalk Radio.
And these questions,
these are questions from our listeners.
Yes.
And we got some seriously knowledgeable listeners out there.
Yes.
Very impressed.
These questions are very challenging.
Yeah. And so what we try to do is spend some time of our StarTalk airwaves just receiving and responding to cosmic questions shared with us on our Twitter stream, on our Facebook page. You can find us on Facebook and like us there, of course, or find us on the web at startalkradio.net. And we have a Twitter stream, StarTalk Radio, and all these places you can send in questions and we collect them. In this particular case, we've got all the ones just about general astrophysics.
Yes.
Yeah. And you're going to read them to me, and I haven't seen any of these questions in advance.
And I wish you had, because I need some help. I don't know when I've ever felt this inadequate mentally.
All right. So mentally was the clarifying word there.
Yes.
All right. So give it to me. What do you got?
Okay. Our first question is from, I believe this is Jin or Jisin Divs, DVS. Could the Big Bang be the destruction of supermassive black holes?
Ooh. So the Big Bang itself is what birthed all the space, time, energy, and matter of the universe.
Yes.
So once the universe began to expand and the matter coalesced into objects like stars and galaxies. And every large galaxy we know has a supermassive black hole in its center. Only one. There's no room for two. If there's ever two, they will soon merge.
Okay.
And become one mondo.
The alpha.
The alpha black hole. Yeah. So what happens is you can have galaxies that collide with each other. And their black holes, sure as night follows day, will find each other, merge, and become the new center of that mega galaxy that just formed. Because galaxies collide. They go bump in the night.
Right.
Yeah. So can they destroy supermassive black holes? No. A black hole is a black hole until it evaporates using the special... Did you know black holes evaporate?
No.
You didn't know that.
I had no idea.
You got to come more often.
That's what I'm saying.
Or get out more. You know, if you get out more, you would learn this.
Yes, so this is general casual conversation. Hey, everybody, black holes evaporating over on 15th Street. What?
So it turns out Stephen Hawking showed, among many discoveries of Stephen Hawking, we all know Stephen Hawking, the brilliant physicist at University of Cambridge, England. So he proposed, he discovered, using quantum physics, the laws of quantum physics, that sort of particle by particle, a black hole slowly evaporates. And the black hole in the center of a galaxy is large enough, it would take about 10 to the 100th years, a Google years, to evaporate. Did you know 10 to the 100th is a Google?
I had no idea.
Yeah.
Does Google know that?
Google, they're spelled differently. They put the L in front of the E. Google, the number, 10 to the 100th power, a one with 100 zeros, is spelled Googol, Google, as opposed to Google.
Oh, got it.
Yeah, Google. So that's way longer than the age of the universe. So this is not something you should wait around to watch happen.
That's not a quick cup of tea.
Right, no. And so in the birth of the universe, there's no reason to think that if somehow another universe got born, that it would destroy a black hole that was adjacent to it, because black holes really have their own agendas, and it is matter gone bad.
I love that. They have their own agenda.
Well, they don't care what's happening
matter gone bad
around them. They don't care. There's supermassive centers of gravity and mass at very high density. Some new law of physics would have to rise up that we would then discover to show how you would then tear apart a black hole or destroy it. But there's no known force large enough to accomplish this.
All righty then.
Yeah.
Moving on.
What else you got?
All right. This is from Mikhail Gorbax. About the accuracy of the age of the universe and the Hubble constant, how are we able to refine the 12 to 14 billion year estimate to 13.75 billion? Which, that's really rude. Lady doesn't like to tell her age. Does the universe really want you knowing that it's 13.75? Couldn't we go with the estimate?
Back up. For the longest time, in fact, my entire time as an undergraduate and in graduate school, we didn't know the age of the universe by a factor of 2. There was some research that indicated that we might be 10 billion years old. Other research that indicated we might be 20 billion years old. And there were warring camps at every conference. There were the 10 billion-year-old people, the 20 billion-year-old people.
What did that fight look like in the lunchroom?
In the lunchroom? Yeah, what foodstuffs did we reach to throw at each other? And this all relates to what's called the Hubble constant.
Okay.
Named in honor of Edwin Hubble, the man. There was a human being that predated the telescope, whose name was Hubble.
What you say?
Now, here's an interesting case. He had an affected British accent.
Did he really?
Yes. He was so fake and wore all these tweedy things. He smoked a pipe.
I love it.
And he was a misogynist racist. Totally.
Well, if you're going to be one, you should be the other.
They go together.
Two for one.
They often go together. And the good thing about science is that none of that's relevant. What matters is how good was his science. In many other walks of life, you fold all that together and you say the person is reprehensible.
Right.
I don't want any part of them. I don't want them speaking to my children. And in science distinguishes itself from other activities of the human condition for that reason.
Right.
It's got nothing to do with culture. That's right. So he, in the 1920s, discovered that galaxies in the universe were moving away from one another in all directions. And so you look one direction, they're moving away from you. Look another direction, they're still moving away from you.
I want my space.
It's not
I'm out of here.
I need my space. They're not coming towards you in one direction and away from you in another. They're going away from you in all directions. If you plot this up, the line that is drawn has a slope.
Okay.
The slope of that line is the Hubble constant. And if you know the slope of that line, you know the age of the universe.
Oh.
So the Hubble telescope was first designed to get the best, most accurate measurement of the Hubble constant. So the battle of the Hubble constant went from 10 billion to 20 billion, and then it was like 10 billion to 15 billion, and it got narrower and narrower and narrower. And finally, we refined that slope of that plot, and we can say the universe is 13.7 billion years old. We got to take a break. We'll come back, more cosmic questions on StarTalk Radio.
You were born, and soon you will return from a stardust-covered universe where the end is certain, but it will not be rehearsed. This is StarTalk.
This is StarTalk Radio. We're back. I'm Neil deGrasse Tyson. My co-host today, Leighann Lord.
Yes.
Comedian.
Extraordinaire.
Do people come up to you, they know your profession, they say, tell me a joke?
Yes.
Yeah, don't you want to hit them?
All the time. And I have. So there's an issue.
You're still resolving this within you.
Still resolving.
Yeah.
Case is pending. I can't discuss.
So I've got you here to read me these questions that came in from the internet. And I haven't seen them before, but they're all about modern astrophysics.
Yes.
And they came from our listeners, and we're just trying to give back. In this, the Cosmic Queries part of StarTalk. So what do you got?
I have a question from Tony Schultz, and he says, regarding a subject brought up on the Origins TV series, why...
The TV series that I hosted for PBS Nova.
Nice plug.
I'm so people know. Just so they know.
Uh-huh.
Okay, go.
Moving on. Why is it even a question whether our solar system came from a supernova explosion? I mean, how else would heavy elements like gold on Earth come from?
Well, what a luxury it is to retrospectively assert that, of course, our heavy elements came from supernovae.
I know, right?
This was not known for a while. Do you know when I was a kid? And I'm in chemistry class, and you ask the chemistry teacher, where did these elements come from that sit up there on the periodic table? So we find them in the ground. That was the chemistry teacher's answer. You don't get the real answer to that question until you take astrophysics, where you say, where do these elements come from? They are cooked in the crucibles of high-mass stars forged from small elements like hydrogen and helium. They are fused together to make high mass elements. And they ride their way up the periodic table of elements. And then that same star explodes, scattering its guts into the galaxy, out of which you make subsequent solar systems. Somebody had to discover this. A Nobel Prize was awarded for that discovery.
You know, if they explained it like that in high school, that was like the opening of a movie. There was forging and explosions oh my God.
Is this how it goes?
My science class was not that interesting.
And so, but in a TV series on Origins, you can't assume people know that in advance. No. And how heroic it was to deduce the fact that these heavy elements owe their origins to stars that have given their lives so that we can live.
Wow. I love that.
There you have it.
Moving on.
StarTalk, the Cosmic Queries session.
I love it.
Leighann, what
Don't
else
assume. I like that. Okay, this next question is from William M. Saccharin. And he says, there's a Google Nexus commercial where a girl asks Google, Google, how much does the Earth weigh? And the device responds with, the Earth has a mass of... I mean, obviously, mass and weight are not the same measurement, but this made me wonder, how do you measure the weight of a planet when it's the planet itself that provides the gravitational force by which you make the measurement?
Ooh, well, a couple of things. So if you say, what is the weight of something that's a physical object, we assume you mean, what is its mass? We have to assume that, yes.
Okay.
Hence, the answer comes back with a mass number, not a weight number. Earth is in free fall towards the sun with sideways motion that keeps it in orbit. And anything that's in free fall towards anywhere is weightless. So you could justifiably say the Earth is weightless in space because that's true.
Wow.
Earth has no weight any more than an astronaut has weight in orbit around Earth itself. So in other words, for the same reason that astronauts and space stations and the space shuttle is weightless in orbit around Earth, Earth is weightless in orbit around the sun is weightless in orbit around the center of the galaxy.
So the minute we stop moving fast enough...
Oh, if we stop moving sideways, then we fall directly towards the sun. If the space station stops moving sideways, it'll fall directly down towards Earth and crash about 15 minutes later.
So the Earth is a svelte nothing. Is what you're saying.
It weighs nothing, but it's got mass. So when people go on weight loss programs, what they're really doing is trying to lose mass. Because if you want to lose weight, just go into orbit, and then you weigh nothing. But what we're really trying to do is remove atoms from your body.
Yes.
That's what you're trying to do.
I really am.
Fat atoms.
Yes.
They're molecules, fat molecules. That's what you're trying to remove from. There's no element on the periodic table called fat. It's a rather complex.
We have a different table, sir.
It's a rather complex molecule that has a lot of stored energy. That's why fat is it's an extraordinary. That's why you can go for days and days before you burn off all the fat layer that might have accumulated on your belly or on your butt. So, getting back to the person's question, Earth is weightless because it's in free orbit around the sun, as in anything that's freely falling towards anything else. So the moon is weightless in orbit around the Earth, just as Earth is weightless in orbit around the sun. So now you want to measure the mass. Mm-hmm. Okay, that was done by a fellow named Cavendish, and he's a British, actually, I think he was a chemist.
But real British, not affected.
No, I always get it confused. If you're British or English or from the UK, I always get, every time I learn it, I never retain it.
Right.
And so I'll say he's from somewhere in the United Kingdom, all right? But the point is, he was the first to measure the mass of the Earth.
Okay.
And it's a hefty number. What's useful about...
The Earth is a little chunky.
Yeah, so the mass of the Earth, we get 6 times 10 to the 27 grams. So if you want this in tonnage, that would be, let's see here, that would be 6 times 10 to the 21 tons. So 6 sextillion tons.
Wow.
Yeah.
The Earth is a brick house.
Now, what's useful about that number is if you want to know what happens to Earth if we get hit by an asteroid, find the mass of the asteroid.
I was about to say, doesn't it depend?
Well, yeah, exactly. So you look at the mass of the asteroid, compare it to the mass of the Earth. It's like a mosquito flying full speed ahead into the buttock of an elephant.
That's an image.
Or a gnat. A gnat is better than a mosquito because gnats just they're annoying and they fly into you. So the relative mass, I think when the last time I did that calculation, that was about right.
Okay.
All right. So asteroids are bad for life, but they're not going to harm Earth. When people say save Earth, Earth does not need saving from anybody. They mean save life on Earth.
Right.
Yeah. So you can so you do it with an experiment. If you Google Cavendish, you'll read all about his experiment where you can measure what's called the gravitational constant, which was first predicted by Isaac Newton.
Okay.
And once you know that constant, you can calculate the mass of the Earth. It rolls out of the equation that you just used.
Wow. All right, William.
You got it.
Thank you for your question. Moving on, I have a question from Ken Duncan.
Yeah.
And he says, Dr. Tyson, where does all the spin in the universe come from? Planets, solar systems, galaxies? I'm thinking Madison Avenue.
Spin from Madison Avenue. That's the best place for spin there is. Everything spins. Everything.
So when little kids do it, mommy shouldn't say stop?
Everything. Mommy should never tell kids to stop doing anything.
Hold on now.
So everything spins. And you say, well, that's odd. Why is there anything that doesn't spin at all? Take a huge gas cloud, all right, for example, in the galaxy.
Mm-hmm.
If there's any movement at all, like 1 atom's width per year, if anything is moving in it, as the gas cloud collapses, the speed of movement increases. This is why if you suck a strand of spaghetti through your lips, it is guaranteed to flap you in the face.
Guaranteed.
Guaranteed. Try it.
I know what I'm eating for dinner tonight.
Try it, okay? Start at the bottom of the spaghetti.
Okay.
Make sure there's not a loved one at the other end of the spaghetti.
Oh, that would have made
This experiment wouldn't work.
Okay.
It's got to dangle below. You suck it up in your mouth. Initially, it's wiggling just gently.
Mm-hmm.
As you suck it more and more, it starts wiggling more violently.
Yes.
And then eventually it slaps you in the face. I'm just saying.
Yes.
Okay, so this is a major principle in physics called the conservation of angular momentum. That's what it's called. And skaters know...
It's not called flapping spaghetti? That would be so much easier to remember.
I should rename it. Yeah, the flapping spaghetti rule. It's skaters that pull in their arms and they spin faster.
Oh, yeah, of course.
If you start out with even the slightest speed, you will speed up as you collapse. And everything in the universe, because of gravity, collapses. And whatever speed it had before, it speeds up. This is why everything in the universe rotates. We got to take a quick break. More from Cosmic Queries when StarTalk Radio continues.
Hey, it's time to talk about Squarespace. You know, it's one of my favorite supporters of StarTalk Radio because I built my website with Squarespace, and I'm excited to tell you that you can do the same thing. Whether you need a landing page or a blog, a gallery, or a website, Squarespace is for you. It allows you to create your own website the way you would like it and do it in a simple, intuitive process where you can arrange all your content any way you want. Here's how it works. Squarespace provides you with these beautiful templates that you can arrange any way you'd like to make a highly customized website that is unique to you. If you can drag and drop a file, then you can build your own website with Squarespace. And if you have a problem, don't worry about it. They offer 24/7 customer support, and everyone there will be able to help you. They know exactly what they're doing. Let's say your website is for commerce. Well, Squarespace gives you all the tools you need to track inventory, process orders, send custom emails in one intuitive interface. And when you're done building your site, it will scale to any device, and you don't have to do a thing. That happens automatically. So here's what you need to do. Start your free trial today at squarespace.com and enter offer code StarTalk to get 10% off your first purchase. Remember, that's squarespace.com. Enter offer code StarTalk and get 10% off your first purchase. You know, we get emails from you all the time asking for ad-free StarTalk episodes and more video. Well, we've heard you loud and clear, and we're thrilled to announce the launch of StarTalk All Access, a premium subscription service that offers these things and more. StarTalk All Access is your universal hub for all the great StarTalk content you crave, all in one place. Enjoy StarTalk Radio and StarTalk All-Stars episodes streamed ad-free, along with full video of current episodes, live-streamed StarTalk Live podcasts, exclusive original all-access content, insider-only looks behind the scenes, the ability to watch on Amazon Fire, Apple TV, and Roku, and new content added every week. And speaking of original content, how about you check out what's up on All Access right now, which is a full video of Neil deGrasse Tyson, astronaut Mike Massimino, Dr. David Grinspoon, or as I like to call him, Dr. Funky Spoon, and Chuck Nice sitting around a table, drinking and getting a little bit wasted. It's actually a cool video. Look, to get started, visit StarTalkAllAccess.com to subscribe for $4.99 a month with a 2-day free trial. That's StarTalkAllAccess.com. Enjoy StarTalk All Access, and as always, keep looking up.
The future of space and the secrets of our planet revealed. This is StarTalk.
Rock, y'all. Freak, y'all. To the beat, y'all. Momentum. Set it off now. Keep it rolling now. I want to turn it out.
We're back on StarTalk Radio. Of course, we're on the web, startalkradio.net. You can download our archival shows. They're fun. If you're a new listener to StarTalk Radio, we've been at this only for a couple of years, but there's some cool guests that we've had in the past. Check it out. And we're also, of course, findable on iTunes. Just find us on StarTalk Radio. Leighann Lord, you're my co-host today.
Yes, I am.
Great to have you.
And I'm loving
You're
it.
reading me Cosmic Queries.
I
and
am.
This session, they're just general astrophysics. It's the grab bag bin of cosmic questions sent to us by listeners from our Facebook page. So what do you got?
Well, you know, I'm feeling richer and smarter with every question.
Excellent.
I've done the spaghetti thing. I got to be honest.
Oh, the spaghetti, coming off the break.
Yeah.
You suck spaghetti through your lips and it flaps in your face.
And I had no idea there was a physics principle going on with this fun.
Major law of physics operating, getting spaghetti sauce in your face. Now, I think as adults, we don't do it as often, right? Because because you flap food in your shirt and all this sort of thing. So, but kids certainly remember this. And it's a major law of physics. It's the conservation of angular momentum.
Wow.
And so what it means is if you're rotating slowly and you have a big extent to your physical system, and then you start pulling things in towards your axis of rotation, something's got to compensate for that. And the way you compensate is you end up spinning faster. And there are equations that prescribe this with precision.
I'm a rollerblader, so yes.
Oh, yeah, you know it. Oh,
yes,
yeah.
So
you got it.
I didn't know. I should have known it was physics.
Yeah.
I just know, oh, wow, I'm faster. All right, I have more questions, if that's okay.
Yeah.
William Jesse Miller has a question. And William asks, how does a planet...
It's another three-name person.
Another three-name person.
Maybe they're feeling it with my Neil deGrasse Tyson, so they got to come in with 3 names.
Yeah, I feel that's how they got to get their entree.
William Jesse Miller, go.
How does a planet have 4 suns? Wouldn't some stars be ejected? I thought 3 or more star system is unstable.
How does a planet have 4 suns? Okay, yeah, sure. So the universe, if you look up at night, most of the stars you see are not alone. More than half of the stars in the night sky are double and multiple star systems.
Okay.
And so the solar star, like Earth, like our sun, is I don't want to call it rare, but it's not the most common case in the galaxy.
Really?
Yeah. And what a surprise that was to the first person with a telescope who looked up and saw, hey, that's not one star, that's two. Oh, it must be a chance alignment of a star in the foreground and a star in the background, they said to themselves. Then they looked around and they said, wait a minute, too many stars are close to each other than the randomness of stars in the galaxy should allow. If you just randomly throw stars up on the sky, how often are they that close to one another?
Right.
It should be rare, yet it was common. So the original research paper did this statistical calculation and concluded this must be real. There must be actual double stars up there. Hey, there's a triple star. There's a quadruple star. You keep looking, whoa, we have a whole cluster of stars. A beehive of stars. In fact, there's an actual cluster called the Beehive Cluster. And all these stars orbiting a common center of gravity. Yes, occasionally you get an ejected star because not all orbits are stable when you have all this action. But there is what we call a parameter space where, think this through, right? Two stars orbiting close to one another, it's a tight orbit.
Right.
Now you pull one out a little kind of far. Have that orbit that pair. It's orbiting so far away, it thinks it's orbiting one star.
Wow.
So that's stable.
Okay.
Now you get a fourth one, pull it far away. Make it so far away, it thinks it's orbiting sort of one gravity field. The questioner is right. Jesse's right. When you orbit really close, what path are you going to take?
Right.
Who are you next to now? Something different tomorrow. That could be hugely turbulent, hugely unstable to the orbits within the system. But you can configure a system where you have a whole set of stable orbits and everybody's happy. You know another set of stable orbits? A pair of stars here and a pair of stars there, and those pairs orbit each other.
Aww.
Right? Isn't that cute?
Like dancers.
So that'd be a double star.
double-double.
And they're actual stars in the night sky, visible to the naked eye, that are double.
I feel like I'm ordering Tim Hortons
the
coffee.
universe.
That's great.
So now I'm thinking about it. The question was, how does a planet orbit safely around four suns? That's what his question actually asked. I'm talking about how do you get four stable suns to begin with?
Oh,
yeah. So now, if a planet were among the stars, it's not stable. It'll fly away. Right?
The planet will fly away.
Yeah, if the planet is orbiting within the orbits of the stars themselves, it's going to fly away.
So you're saying the planet is commitment phobic?
It's totally commitment phobic. It needs one sort of committed feeling.
So it can't be big love.
It's got to go in one direction. So in Star Wars, where they had the double sunset planet, the double sunset, those two stars are close enough to each other, and the planet is far enough away from both, so that it executes one orbit around both.
Okay.
That's how you pull this off.
But four, not going to work.
Your four, if you can start moving in and out, what's your allegiance? As you get pulled to one star versus another, and it wreak havoc on the planet, and you just get ejected. In fact, you know something? We think most planets in the universe were ejected in their early solar system. And they're floating free in space, and they're called planetary vagabonds.
Aww.
And if any of those planets have internal heat sources, like geothermal heat that doesn't require a host star, maybe there's life on those planets. And it might be that life is teeming far away from stars in this galaxy.
Wow. That's a possibility?
Yeah. So we got to take a break. StarTalk, the Cosmic Queries edition. We'll see you in a moment.
Future of space and the secrets of our planet revealed. This is StarTalk.
This is StarTalk Radio. I'm Neil deGrasse Tyson here with Leighann Lord, comedian. Leighann.
Hey.
Thanks for being here on StarTalk, and you're reading me questions today.
I am.
On the universe, submitted by listeners, posted on our Facebook page, and I'm ready for them.
Well, are you ready for Ryan Smith, who wants to know if light has no mass, why does the gravity of a black hole affect it?
Ooh.
This is right up your alley, sir.
Ooh, bring it on. Bring it on. Yeah, light has no mass, but light has energy.
Oh.
And you need to rethink of what mass is. Mass, this is how to, let's move forward into the future, thinking about the universe in this way.
Okay.
Okay? Mass can reveal itself as either matter or energy.
Okay.
All right? That's a way to think about it. And so, therefore, light, which has energy, has a mass equivalent to that energy. And since a mass has gravity, a gravitational field will pull a beam of light into it. Not very well, it turns out, unless you're a black hole. You got to totally tear a new one through the fabric of space to pull a beam of light into your surface. So, light beam coming by Earth bends a little bit, barely perceptibly. Light coming by the sun bends perceptibly. That got measured in 1919 when, after Einstein predicted it, Sir Arthur Eddington, an astrophysicist, brilliant dude from England, measured the bending of starlight as it came by the sun during a total solar eclipse. You can't see the stars. You can't see the stars in broad daylight. But you want to see a beam of light coming by the sun to see if the sun tugs on it in a measurable way. You wait for a total solar eclipse. The light of the sun is blotted out. There's starlight behind it. You know where the image of that star should be. You measure it. It's in a different place. The light bent on its way coming around the edge of the sun to get to your telescope. You measure how much it bent. Bang on. It's Einstein's general theory of relativity with gravity field bending the curvature of space, and it curves the path of light. But I shouldn't say it that way. You know how I should say it? I should say...
With a deeper voice?
I'll say it with a deeper voice. Gravity curves the fabric of space and time, and light travels on that fabric. So it's not that gravity curves light. It's that gravity curves the very nature of the space-time continuum. And all light is doing is following that form.
Wow.
Yeah, so that's why. That's why. Light is following the path of space, and a black hole curves space, light goes in right alongside it.
So light is along for the ride.
It's along for the ride, exactly.
Light
So
is in the
it's wrong to say that gravity curves the path of light. Gravity curves space. Light, as far as it's concerned, is always traveling in straight lines.
As far as it's concerned.
As far as it's concerned.
Okay.
But if the space happens to take it in a curved path, that's space's problem, not the light. Okay.
Officer.
All right. Yeah.
I was in the car. I had no idea what was going to happen.
Think about it on NASCAR, because I know you're a big NASCAR fan.
Huge. Huge. As I get in my hoopty speeding down the Belt Parkway. Huge.
So in NASCAR, there's this joke about NASCAR drivers. You know, can they, in real life, are they always just turning left? Do they ever know how to turn right? Well, that's actually not an accurate joke. That's like a scientifically flawed joke, right? The track is banked in a NASCAR track, right? Of course it is, right? It's banked. You know why it's banked? I'll tell you why it's banked. If you are driving at the right speed for that bank, you do not have to turn the steering wheel, and the track will turn you. So as far as the car is concerned, it's going in a straight line.
Yes. Wow.
They don't ever have to turn the steering wheel to bank those turns.
But they've got to be going at the right speed.
At the right speed, exactly. And so it's banked for a particular speed, and depending on the slope of the track. So when they're steering just to maneuver in front and behind each other on the track.
Right.
Yeah. Oh, yeah. So that's a car driving in a straight line with the space-time continuum of the NASCAR track curving its path into a U-turn.
Oh, man.
Oh, yeah.
That is so cool.
Yeah, it feels good. It's good for you. It's good. Okay.
I have a question from Angie Suave. I love that name.
She's Rico Suave's sister?
Sister, absolutely. And she wants to know...
How do you say it? Rico
Suave. How sad is it that we know that?
I know, right? That is so sad. We got to get a life.
We're lame.
Later.
We lost our street cred. All right. Could we send a probe of some kind into a black hole? I realize it would be destroyed, but couldn't it transmit some relevant data, at least for a short time, on its approach? And have we already done this?
We have not already, excellent question. We haven't already done that. We're not close enough to a black hole to even think about that experiment.
Really?
Now, the dangerous part is, suppose a black hole comes our way. Like, first, how would you know it was coming if it's black? Space is
Seriously?
black. I know. Well, I'm saying. So what you have to do is you look for the distortion of space around it, right? So you have a star field. If all of a sudden the star field starts looking like a funhouse mirror, run.
Just pack up the planet.
Back up the planet and get the hell out of that solar system because a black hole is on its way. As a quick aside, most of the black holes we know, we detect from... because they're in a binary star system. There's another star adjacent to them being flayed. Love that word.
I do.
A rare word. It means getting skinned alive, by the way.
Yes, very Middle Ages.
And you're a word person because you tweet word of the week. It's very Middle Ages, right? It's very like Spanish Inquisition. So a black hole can flay an adjacent star. If it becomes a red giant and its outer shells expand too much, that it'll then remove those outer layers and those layers will descend into the black hole. Our X-ray telescopes detect material descending into a black hole that gets heated on its way down because of the friction of the disk that it makes. It basically gets flushed toilet bowl style.
Right.
And as it descends down, it releases energy that it has from falling, and that energy is very high. It's like X-rays. X-ray telescopes detect black holes in the galaxy. There's none that we know of that are nearby.
Lucky for us.
Lucky for us. But if we did send a probe, yeah, we could get some fascinating data on the gravitational field, the radiation field, and we get it all the way until it hit the point of no return, the event horizon. I love that.
Clearly.
It's a poetic term for the place where you're never coming back.
Right.
Because within the event horizon, even if you could travel the speed of light, it's not fast enough to escape the gravitational field of the black hole. So... there you have it.
Is there something, are there plans to do this? And can we really get some knowledge from this?
Yeah, we could get knowledge, but I'm saying there's no plan. We don't know our own solar system, much less trying to poke around in a black hole.
Right.
It's like, stay out of that. Don't play,
Right.
We got to choose our playpens and our sandboxes.
Don't poke the bear.
Don't... Until that day comes. If we were to find a black hole, I'd try to find a way to exploit its gravitational field for the purposes of the production of energy. For example. That'd be cool. Yeah.
Reduce my light bill.
That'd be good.
I have a question from Gary Routh, and I love this. Is there dark matter in my bedroom right now?
I love it.
Dark energy? Is it inside of me right now? Dark energy is, I guess, but dark matter, I'm not sure about. Also, if the universe is expanding, does that mean that I'm expanding too? This is a Dexter question.
This is golly.
Dark matter in me right
I got
now.
like 2 minutes left, and I got to I don't know that I can answer all three in 2 minutes, but I'll try.
Okay.
Dark matter, we don't know what it is, but we know where we can find it. But I can tell you that if it's in your room, there's not much of it.
Okay.
Dark matter does not interact with our matter. It doesn't interact even with itself. That's assuming that it's matter at all. So you don't have solid dark matter planets.
Okay.
What does it take to make a planet? Matter has to interact with itself and make molecules and cling together and make rocks and molecule and people and places and things. Dark matter has no such properties. That's why it's diffuse across the galaxy. We have what's called a dark matter halo around our galaxy. And all the dark matter is scattered into this halo. Huge quantities of matter. I don't even know if it's matter, but it has gravity. And it's huge. But it's so dispersed. And so that there's not a meaningful amount of it in any localized place that you're going to find.
Very antisocial.
Yeah, very antisocial. And dark energy, that's everywhere you find the vacuum, you have dark energy. The vacuum of the cosmos itself. Yeah. So, and when the universe expands, are we expanding with it? The molecular forces that keep your body together, those molecular forces are stronger than the force that's expanding the universe.
Thank goodness.
So as the universe expands, you don't.
Oh.
Neither does our galaxy.
Well, until you hit middle age, and then it's all downhill from there.
Or
baby.
the solar system. We've got to wrap this up. Leighann Lord, thanks for coming.
Thank you for
My
having
gosh.
me. I have so much fun here,
Excellent.
and I learn so much.
And I hope people will follow you, because I follow you on Twitter, so I hope others will follow you too. You learn a lot and laugh a lot. When we come back, I'll be with special guest Bill Nye, the Science Guy, along with co-writer of Cosmos, Stephen Soter, who dropped by the Cosmic Crib to share their personal experiences with Carl Sagan.
You know that we are always grateful that you are listening. And if you have an extra minute, please go to podcastsurvey.net to take a very short anonymous survey about today's episode. It would be a big help to the show. And of course, I would appreciate it. Again, that's podcastsurvey.net for a quick survey to help the show. Thanks so much, guys.
The future of space and the secrets of our planet revealed. This is StarTalk.
Cosmos is also within us. We're made of spark stuff. We are away. The cosmos and know itself.
We're back on StarTalk Radio, and this is the Cosmic Crib edition. And in the Cosmic Crib, these are conversations that I conduct with friends, with colleagues, with strangers. And it takes place in my office here at the Hayden Planetarium at the American Museum of Natural History. The Cosmic Crib today, I've got the one, the only, Bill Nye, the Science Guy. Bill, welcome to the crib.
It's good to be in the crib, Neil.
In the crib. And I also have Steve Soter. Steve Soter is co-writer of the original Cosmos television series in 1980.
More significant than that, I think. Steve Soter gave me an A on my paper in astronomy class.
We'll get there. We'll get there. So Steve Soter also co-wrote the modern Cosmos, A Space-Time Odyssey, along with Ann Druyan. And there's something that all three of us have in common. What is that?
Carl Sagan?
Carl Sagan.
I knew it.
We've all been touched in some way by Carl Sagan. So, Bill, you were a student at Cornell?
Yes.
Did you take a class with Carl?
Yes.
How did you do?
I don't remember, but I think I did
Okay, that
well.
means you didn't.
I think I did well. It was an
I think
elective.
people got A's remember that they got A's.
Well, so that's the main thing. I got an A on my paper.
Okay.
And so
What was the
I
class
got
in?
an A in the class.
What was the class in?
Astronomy, solar system.
Okay, I suppose I could have guessed that.
Yeah. No, but I took it as an elective after I had accomplished all my mechanical engineering.
What year in school were you there?
Senior.
Senior.
So I took a freshman
And you
course,
majored in what?
mechanical engineering.
So you're ME, all right?
Yeah.
Cool.
BSME, we say. Bachelor of Science Mechanical Engineering.
Uh-huh.
And I took astronomy as an elective on a whim, and it kind of changed my life.
Changed your life. Why?
First of all, I got a deep appreciation for this idea that we are all made of star dust, star stuff.
I'm partial to dust, by the way, but
I know you are.
Carl and stuff go together, right?
Stardust memories, yes, it's kind of has a romance. The dust has a romance. Also, my father was quite the amateur astronomer, or interested in astronomy.
And in astronomy, when you say amateur, it's actually a badge of honor.
I know. I
Yeah.
had to stop myself.
No, it's good.
A
It's
serious amateur astronomer is a serious
a serious thing.
undertaking.
Very different from amateur neurosurgeons.
Yes, yeah, for example.
Amateur attorneys, you would not give them business.
Today, amateurs are actually discovering extrasolar planets.
Yeah. The amateur astronomers are rocking. They got
Yeah,
great
I'm
backyard
down. I'm
telescope.
hip. Now, through knowing Carl Sagan, an amateur astronomer found, at the Planetary Society, found an asteroid, 2012 DA14. So I have tremendous respect for the expression amateur astronomer. That aside, my father could name you 50 constellations out of 88.
Yeah, that's good.
And if he were to set back, and he could tell you all of them, but they're not visible from the northern sky, in the northern sky. And he taught astronomy merit badge in the Boy Scouts. My father.
You were a Boy Scout?
I was a very good Boy Scout.
Wow.
I'm a tinkerer.
You're like total all-American guy.
Sort of. We're missing a few things.
Boy Scout.
But I had a great experience in the Boy Scouts. I mean, I meet people that had a miserable experience. I had a great time.
Yeah, okay.
And this thing, if you were stuck in the woods, get out of the woods. So you're stuck on the island, you're lost. Well, get off the island, for crying out loud. Now, I'm sympathetic.
Yes, Mr. Professor.
If Marianne is there, I could see him being motivated to stay on the island.
This would be Marianne from Gilligan's Island.
Yeah. Mm-hmm. But just in general, like the Blair Witch Project. Sorry, get out of the woods. Follow the stream down the hill and get out of the woods. What's wrong with you people?
Because all streams go downhill.
Pretty much. And little streams generally lead to big streams. Yeah, pretty much.
Eventually to the ocean.
Yeah, pretty much.
So, Steve, you were also at Cornell.
Yes.
You obviously overlapped with Carl. Did you overlap with Bill?
Yes.
I guess no. Bill said you took a class with Steve Soder.
He gave me an A on my paper.
Well, I was helping Carl sometimes grading papers for his class and giving lectures.
Were you like a TA?
When he was traveling, yeah.
Wow.
I thought you were so hiply down with that, Dr. T.
No, I don't know. I don't get all in people's business. So you but you had enough control over class to assign grades.
Well, I think I graded the papers, graded some of the exams.
Yeah. And you gave Bill an A.
Yes, I don't remember the paper, but I remember that I gave him an A because he's reminded me many times.
No. You
Bill, it's an implanted memory.
Oh.
It's an implanted memory.
You claim you remember.
Well, I've forgotten it now.
It was about Curlian photography.
Oh, okay.
Oh, this is a pseudoscience thing.
Yes.
Yeah.
Yes.
And I had a picture of a dime giving off coronal discharge.
Right. This was a course. I think the paper assignment was to investigate some pseudoscience or borderline science and get to the source and try to find out what's really going on here. And he did it on curling photography and did a first-class job.
And this is not an implanted memory that Bill constantly...
No, I remember it now.
Now you remember it. Yeah. And did you see promise in Bill, or was he just another student at the time?
I don't know that I met him personally, so
No, he's sitting right to your left.
No, at that time.
Note that in English, the expression right to your left is meaningful.
I don't give easy A's, so that was an impressive paper.
Okay. Oh, excellent. So, Bill, you had some promise.
In that one area.
Okay, so I did not go to Cornell. Now, in Cosmos, we did not complete that story. And I didn't even realize we didn't complete it until I'm sitting back at home. I say, wow, nobody knows where I actually went to college.
Not only that, after you tell the story, everybody figures, well, that's why I went to Cornell and I Carl Sagan and got inspired. But no, that's not how you roll.
So in Cosmos, in episode 1, and we reprise some of it in a later episode, I retell the story of when I first met Carl Sagan. And, I was applying to college, and I got accepted to Cornell when it was one of my...
Shocking.
It was one of my...
No, of course, they pleaded with you to come there.
And I didn't know they sent my application to Carl Sagan to get him to well, first, I think, to assess whether I'm somebody worthy of his attention.
You were worthy.
That's got to be in there somewhere, because my application was dripping with the universe, because I've known since I was 9. And so he then sent me a personal letter. Couldn't freaking believe it. I still have the letter. It's hand-signed.
I'm down.
And I'm thinking, and I said, is this Carl Sagan? Because back at the time, he was already on Johnny Carson.
Yeah, so we used to whistle.
The then hoster of The Tonight Show. And
he would come into class.
Best-selling books. Yeah, so this is how we all knew Carl. Now, I have my best Carl story after that, but do you have a Carl story you can share?
Well, I went to my 10th reunion.
But just for people who are completely not knowing what's going on here, Carl Sagan was a professor of astronomy at Cornell University, and he was one of the first scientists, certainly first astronomer, to make a very big deal of bringing your trade, your research fruits to the public. And this was not an embraced activity at the time. Even Steve Soder confided in me. Actually, he confided in me, so should I? He said when he first heard that Carl Sagan was going to appear on The Tonight Show, what did you think about that?
I was a little shocked, actually.
Shocked, because it's not a documentary, and it's not the news, and it's entertainment.
Yeah.
And you were shocked.
I thought it might hurt him. Yeah.
And he made how many appearances by the time?
Many. Dozens, I think.
Dozens.
Yeah.
Dozens. And you learn that the host of The Tonight Show, Johnny Carson, was an amateur astronomer himself, and that helped for sure.
Yeah.
And of course, where did billions and billions come from? It was Johnny
Carson, not Carl.
Yeah, not Carl. He never said billions and billions, which is not very precise, actually, when you think about it.
There's a great many.
Great,
So,
many
but
billions.
what Johnny Carson, for those of you who don't remember, heard of this guy, what he brought to the table, which was so good about him, was he's curious. He wanted to know.
That's something we're all trying to instill in the world. So do you have an excellent Carl Sagan story?
Well, so I went
That
to
you can tell in like 45 seconds.
I went to my 10th reunion, and I said, Professor Sagan, I'm working on this. I got this idea.
10th college reunion.
10th
at
college
Cornell in Ithaca, New York.
Schmoozed with his assistant.
Are you famous by then?
No.
No.
I'm
you
working
just,
in the
you just
Seattle
Bill.
area, yeah.
You just Bill,
Yeah.
okay.
Working on television in Seattle, and I got this idea for a kid's show about science, and Bill, what have you been working? Well, I had this thing about bridges, and I got this idea about bicycles. He goes, no, don't do technology. He said, focus on pure science. Kids resonate to pure science. That was his sentence. Then I left his office, and it kind of redirected my life.
Really?
Well, the reason the Science Guy show stands the test of time, and it was so successful, or continues to be so successful, is because we focused on
As a major educational element in the school system.
Yeah, it's because we focused on pure science.
Pure
We really
ideas and concepts.
did. Well, as opposed to technology.
Which would look so dated.
Yeah. With that said, we did do a computer show which focused on switches.
Like the dip switches of a computer?
Well, dual inline package switches are one thing, but a transistor.
Showing off now, your name's Steve.
Well, just reminding everybody where dip comes
I
from.
never knew what dip stood for.
It's a 0.1 inch, still the inch standard persists.
Don't be
in
such
that
a dip
industry.
switch.
Anyway, transistor logic, TTL, which runs our world, is based on switches.
Okay, good.
Where
So
a
that's
small
some
current controls another current.
good foundational stuff there.
Yes.
Excellent. You changed the world. So Steve, how about you? Good Carl story?
Well, I just had an impression comes to mind of Carl lecturing, public lecture at Cornell in a big auditorium, 1,000 people. He's walking back and forth on the stage, and he's describing the escape of atmospheres from planets at very upper levels, but molecule by molecule, and he's impersonating the molecules, and he's doing it brilliantly with wonderful sound effects.
How do you impersonate a molecule?
with sound effects
That he made out of his own-
That he made out of his own mouth. Right. He's walking back and forth, and he's obviously having a great time, and the audience is having a great time, and he's got them completely in the palm
He's
of his hand.
personifying evaporating molecules from planetary atmospheres.
Yes, and he's making it exciting and funny, and the audience is hanging on every word, and that was Carl as a real master teacher. He could really convey the excitement and make it fascinating, as it really is.
For me, I attended his, and you were there as well, his Festschrift. He had a 60th birthday celebration at Cornell. And during dinner, there were all these testimonies to him from all around the world, letters and that are read by the organizers. And they were so so filled with praise. I said, nobody could be deserving of this much praise. They're not describing a real person. This is some cult figure. And then later, he would give a public talk in the main auditorium of
Bailey
Cornell,
Hall, I think.
the big hall, and he delivered the most amazing public talk I have ever witnessed in my life.
So you saw the same kind of thing?
It's the same kind of thing. And it wasn't even that talk. It was a different talk. And I said to myself, he is beyond the praise that he received during this dinner that I found so unbelievable. And I said to myself, if I'm ever going to be in a position to give big lectures, I will aspire to be a fraction of what he delivered to us. We got to run. This has been The Cosmic Crib. Bill Nye, thanks. Steve Soder, thanks.
Thank you.
Neil deGrasse Tyson, chilling in The Cosmic Crib.